All right, so let's continue reviewing by looking at 13 and 14, and then I'll do a couple of the applications that are related to 13 and 14. So question number 13 gave you a triangle. The triangle had a 41-degree angle there, 60 centimeters here. This was A, B, and C, and they wanted you to find little a. Okay, so these problems, you're thinking SOHCAHTOA, and you're looking at how, if this is your angle, how this would be adjacent, this would be opposite. So tangent of 41 degrees should equal the A over 60. Okay, then you need A, so you're going to multiply both sides by 60. Here's where your algebra comes in. And A is going to equal 60 times the tangent of 41 degrees. All right, now the problem says find the measure of the side of the right triangle whose length is designated by a lowercase letter. It said round to the nearest whole number. Okay, so it's like find A, round to whole number. Okay, those are the directions. All right, so first off, don't forget to be in the correct mode if you're going to use your calculator. So I'm going to type in 60 times tangent 41. I'm in degree mode, and this turns out to be about 52.15720.427. I'm rounding to a whole number. This is less than 5, so that means this would be about 52 centimeters. And we're done. Okay, these are kind of key problems, but these should make sense. If they don't, get some help from me. Okay, let's see how 14 looks. 14 looks like this. Here's your right angle. This is A, B, and C. I hate that I should have said, by the way, that was a right angle. That's the only reason we can use SOHCAHTOA. And I should have put that in there. It was a right triangle. This one's a right triangle as well. This is what we want to find is the hypotenuse. We know this is 250 meters and angle B is 72 degrees. And so you typically use the information you're given. You focus on the angle. This would be the hypotenuse. This would be the adjacent side for the 72 degree angle. So the trig ratio involving adjacent and hypotenuse would be cosine. So the cosine of 72 equals 250 over C. All right, now we're going to do our algebra skills. We're going to multiply by C on both sides. So we get to here where we have C cosine 72 equals 250. And then we need to divide both sides by cosine of 72. Okay, and so we wind up with C equaling, when you enter this on your calculator, you can just do 250 divided by cosine 72 degrees. Make sure you're in degree mode. When you do, you get about 809.0169944. There's more to it. We just don't see it. And it wanted it rounded to the nearest whole number. This was less than 5. So that tells me the hypotenuse should be about 809. Since that was meters, this is going to be in meters. Okay. All right. That's 13 and 14. Now, what I thought was we jump down and take a look at two problems that are kind of going to look like that once you draw the picture. Like, look at 29. 29, I'm not going to write it all, but it says a plane takes off at an angle of 6 degrees. So here's the ground. Let's imagine the plane taking off at an angle, it's pretty small, angle of 6 degrees. After traveling for 1 mile or 5,280 feet along this flight path, the plane's height to the nearest 10th. Find the plane's height to the nearest 10th of a foot above the ground. So after this has been 1 mile, which is 5,280 feet. It's going along like that. It wants to know, once this is a mile, what's the height? Okay. All right, so you would set that up. You would look at this being your angle. So this is opposite and a hypotenuse. So you would think sine of 6 degrees should equal h over, and what did it want it in? Did it say feet? Yeah, they wanted 1/10 of a foot. So I'm going to use 5,280 feet here. Okay, so I'm going to multiply by 5,280, both sides. And that's going to give me h, going to be 5,280 times sine of 6. And I don't know why I put a degree sign on that. I know better. Okay. I'm watching a TV show while I'm doing this as part of the problem. So multiplying by 5,280 feet on both sides. Okay. And we are in degree. Make sure you're in degree mode. I always check it, even though I think I remember, it pays to double check that. So that turns out to be about 551.9102861. And it said to the nearest 1/10 of a foot. 1/10 of a foot, that's 1 decimal place. The number after this is less than 5, so that's closer to 551.9 than it is to 552. It's closer to 551.9 than it is to 552. Okay. All right, now 30, let me see if I can get another page. 30 is another one that turned out to be a triangle, and then you just have to think about which trig ratio. So here's an application that says a tree that is 50 feet tall casts a shadow that is 60 feet long. So here's my tree. Okay. The sun is somewhere up here. So it's shining a ray. And it's that ray that makes the shadow appear. So here's the tree's shadow. Okay. And it would go all the way to here, but do that a little better. Okay, so there's the shadow of the tree. All right, so now let's see what it says. A tree that is 50 feet tall, so this is 50. Okay. Cast a shadow that is 60 feet long. So this is 60 feet. Okay. And then you're supposed to find the angle of elevation to the nearest degree of the sun. So you want to know theta, this angle right here. Okay. All right. So for that one, this is opposite theta. This is adjacent theta. So I would be thinking that the tangent of theta would be 50 over 60. Okay. And, that would be 5/6. And as a decimal, that's going to go on forever. But what I'll usually do is just leave the 50 over 60 or the 5/6 in there. Here's the one where you don't know the angle. On the other one, we knew the angle. So on all these, this one, we knew the angle. These two, we knew the angle, right? So this is kind of the opposite of that. Now we know the value of the tangent of the angle, but we don't know the angle. That's when tan inverse comes into play. So tangent takes an angle and goes to its value, okay, which if you reduce that would be 5/6. Okay, so we need to take that and figure out what the angle was. Okay, that's tan inverse. That's that button that's above the tan button. So we're going to do tan inverse, which undoes the tangent function. And you could reduce that to 5/6 if you notice that. Okay, so then theta would turn out to be tan inverse of 5/6. Now, when we do that, we wind up with theta being around 39.80557109, and it is degrees because I was in degree mode. And it said, find the angle of elevation to the nearest degree. So it wanted me to round to here. So that would be about 40 degrees. Okay. All right. Now that I wouldn't have to worry about the fact there might be another angle that has a tangent equal to 5/6. Wouldn't have to worry about that because I'm in a triangle, and so I can't have the angles bigger than 40. So that would be, I'd be done at that point. But sometimes this question is harder than you think. Okay. So this was question number 30 from page 598. Okay. All right, let me go ahead and continue and do two other word problems on this. I want to go ahead and look at 27. And let's go ahead and look at 28. Those are two other application problems. They're not right triangles though, so that in a way they don't fit with this video. Okay. In fact, I'm not going to do them on this video. Let me stop the